Thanks for attending this talk on the Federated GraphQL subscription zoo, so the whole landscape around subscriptions, subscriptions plus federation. I'm Tom. I work at Grafbase. We're a high performance, very, very customizable, extensible, and completely self-hostable GraphQL federation solution. So if you haven't come across GraphQL federation before, the idea is very simple. You have multiple GraphQL APIs that we call subgraphs. You take their schemas and you merge them in a process called composition. You have directives for declaratively guiding that merging process. And what you get out of that is a big federated GraphQL schema. You pass that to a federation gateway or router that's based on a standard Apollo Federation v2. So the same schema should work across multiple routers. And then that gateway's responsibility, on top of acting like a regular API gateway, is going to be to plan the queries that it gets against that composed federated schema and orchestrate requests against the subgraphs. Great. So let's talk about subscriptions. Subscriptions are special already in the GraphQL standard. So at the language level, you'd think, okay, query, mutation, subscriptions, they're root objects, they're just object fields, object types. But subscriptions are special, so they are long-lived. You get multiple responses. It's not a single request response. They're also special in that they don't return immediately, so you can do things like introspect the type name on it. You can only subscribe to one root field at a time. So mutation, you can send multiple root fields, query as well, not with subscriptions. So they're special and they're complicated. In GraphQL over HTTP, that defines the standard that defines like the HTTP transport, like the conventions for how GraphQL over HTTP works, and the whole JSON payloads we all know. Yeah, subscriptions are left out. So as you can imagine, there's some fragmentation. There's a bit of a void here, and there's like competing standards for filling it. Now that we've talked about subscriptions and federated GraphQL, how do we combine that? Isn't that complicated? Actually, for a user of subscriptions in a federated graph, not that much. They are regular subscription, and you would use them just as you would subscribe to a regular GraphQL API. So here we have two subgraphs. One that's a stream of sales events with a product ID. And then we have a product subgraph where you can, so we had that at key directive that says you can get the product by ID on that subgraph. I mean, says it to the gateway. And then you have the product name on that other subgraph. So we have two APIs here. What you would have is a merge schema with the products where you can query the ID and the name. And you can send a subscription for, I want the sales, so that sales stream, but I just want the name. So what the gateway is going to do is subscribe to the stream of product IDs that get sold. And then for every single event that it gets, it's going to make a call to the product subgraph and join that type by product ID to get the product name. So transparently, as a client, you get a stream of product names. So that's a nice behavior of federated subscriptions, and on the surface, they're very simple. There are problems, however, with federated subscriptions. So we have lack of transport standardization. We had WebSockets, that was the first transport, and even within WebSockets, you have multiple subprotocols. Subprotocols are something that's part of the WebSocket RFC, and you can negotiate which subprotocol you want, and the JSON shapes in there will be different. So you don't get one payload, one response. You're going to have like init messages and how do you call that? Keep alive, ping pong type of messages between the server and the clients to check that they are alive and all that. And there's multiple competing standards. On top of that, there's server sent events, and there's also multipart transport that's also specified. That's the same transport that's used for defer. So that's already a pretty complicated landscape. On top of that, you have the fact that you get so you get two connections for every single subscription, one from the client to the gateway, and then from the gateway to the relevant subgraph. And these two are stateful. And the worst part, and I'm going to have a slide on that, is multi-protocol subscriptions. What do I mean by that? So you connect with your client to your gateway with WebSockets, and then the gateway is configured to connect to the subgraph with SSE. So you have the gateway is going to maintain a stateful thing and stateful connection and make a translation in between. So that works fine for, okay, sending a GraphQL query, returning a response, that's standardized. It doesn't work well for things like authorization data. So you have headers, that's fine with SSE, but with WebSockets, you can't send headers from a WebSocket in a WebSocket init payload if you're doing it from a browser. So there's, especially inside that in the protocol, in the subprotocols, these connection init messages where you send a payload here where you would send, for example, your authentication tokens. There's a translation there from headers to a JSON payload, and these JSON payloads, they are not standardized in the server implementations that resolve the subscriptions, so you would need to have to do maybe some mapping here, and also, well, a JSON object is case sensitive, headers are case insensitive, so that's really a mess. The only patterns that we've seen for being successful here is either you have control over the whole chain and you standardize on SSE or WebSockets, and then you align your clients and your server implementations, and then the gateways, like all the popular gateways, have options for then just forwarding specific headers or the connection init payload on WebSockets, or you need to do some scripting and some plumbing inside your gateway with coprocessors or whatever extensions, scripts, in order to make that translation. So that just doesn't work out automatically, and that's a hard problem. So there's another way to do federated GraphQL subscriptions, and it's really a different way. It's not an evolution or anything better, but it's also something that's worth mentioning. It's you can connect your gateway directly to a message queue. The idea is that you don't connect to a GraphQL subgraph to resolve a GraphQL subscription from your gateway, but you connect to NATS, Kafka, could be Kinesis, Redis, sorry, and get the messages directly from that queue. So of course you need a gateway that supports that, and as far as I know, there's 2 implementations. There's something built in the Graph Cosmo router that's called EDFS, and then Grafbase extensions. They look very similar, so I work at Grafbase. We're going to look at Grafbase extensions. The Grafbase extensions are basically plugins that you put in your federated gateway. There's open source ones. You can build your own. You can fork the open source ones. It doesn't matter where they come from. And they are basically plugins that define their own GraphQL directives, and the gateway is going to use them for query planning and resolution. They have near-native performance. They're in process. It's a sandbox because it's WebAssembly. It's WASI Preview 2. So you can do things like print to standard out, which was not so nice previously on WebAssembly. You can do arbitrary I/O, and they can act as virtual subgraphs. What that means, we're going to see right now. Virtual subgraphs are subgraphs that are in your federated graph, like a GraphQL API that will be part of your federated graph, except there's no GraphQL server. You just publish a schema, and the gateway plus the extensions know how to resolve the fields on that schema based on the directives that are defined in that extension. So here we have the NATS extension. You see we import it with the link directive here, and we import NATS publish and NATS subscription. We also define an input type for the shape of our data. And then we have a mutation where we define a GraphQL field, what it returns, and then of course its input, and then what it's going to publish to which subject. It's like a Kafka topic or a queue. I mean, it's just the name of the queue you're publishing to. You could select different things on the input. You can do some mappings in there declaratively, but that's just convenience on top. And then bottom half of the second pane on the right, you have the output side, where you are going to have a NATS subscription that can subscribe to different subjects, and then dynamically based on the arguments. And then you have that selection that's a bit more complicated here. It's JQ syntax, if you're familiar with that. It's just a detail of the NATS extension, but it's pretty nice. You can do filtering, rename fields, recompose them, filter them. So here we, for example, take only the product sales where the price is more than 10. Great. And then you see that add drive directive. That's also pretty nice. It's you have a product ID that defines a product entity that's linked to it without having your service like your NATS queue having to care about like putting the product ID inside the product object. Like it has a product ID, we know it maps to a product entity and just derives take care of that. Of course, it's more configurable than this, but I don't have time. Yeah, so you configure that, and you can configure TLS and all that, and that's purely based on the extension and not built in the gateway. So extension space, EDFS is very similar. I didn't show it, but like the extensions look, the directives look exactly the same, more or less, for these simple cases. The advantage of the extension-based approach is like, well, right now we haven't raised that, but it's all JSON. But in your Kafka topics or in your NATS topics, you could have like protocol buffers, Avro, as any other format. XML, what do I know? You can fork the extension and make that work with whatever data format you have. They're customizable, extensible without forking the gateway. You can do that on internal systems, things that don't exist on the marketplace. Yeah, and the filters are nice. Like, I mean, it's a personal preference, but you have this JQ syntax that declaratively allows some data mapping without having to change the extension. So takeaways. Federated GraphQL subscriptions are a bit complicated. They're a bit difficult, but there's ways to make them work. There's traditional federated subscriptions, and that's nice because it's GraphQL. You stay within GraphQL, and you control your subscription resolvers. They are not as nice in terms of performance. Then you have these subscriptions offloaded to a message queue, which of course leave you less control, less flexibility on what you publish to the subscription. But there's performance advantages. So you cut out the subgraph from the equation. You have the gateway talking directly to one of these fast message queues. You can do stream deduplication, which I haven't raised before. But if you have multiple clients subscribing to exactly the same thing and it's public, well, you're going to have as many one connection per client on regular GraphQL subscriptions. With stream deduplication, you have the gateway subscribing once to the topic and then fanning that out to the clients. Yeah, and then you don't have to have GraphQL if you don't want to for the services that publish to these subscriptions. You have external services just posting a message to NATS, posting a message to Kafka, and then your gateway is directly plugged into that without having custom resolvers. And of course, you can mix and match both approaches. There's nothing preventing that. Great. If you're interested in seeing more of that, we have a workshop tomorrow at 10:45 downstairs. Yeah, thank you.